Okay, so we're still working on lesson 15.4, which is just graphing the exponential functions. To be an exponential function, x will be your exponent. We're going to finish up with example 4. Our first equation is f of x equals negative 0.5 to the x power. Just like yesterday, we're going to be looking for the a value, the b value, the y-intercept, and then the end behavior. Okay, first I want you to graph this. So get your graphing calculator or get Desmos. And when you graph it, it should look like this. Thanks. Is there anyone that was absent yesterday? Everybody knows how to do this? Okay. Okay, so there's our exponential graph. Then using this graph and the equation, we're going to come up with the different values. So yesterday we talked about the equation for exponential functions is y equals ab to the x power. So a lot of times when you see two numbers, it's obviously very easy to figure out what's the a and what's the b. So right now it only looks like there's one number there. But I do know that the a value is always the y-intercept. So if you go look at the graph or look at your table of functions or your table of values and find your y-intercept. The y-intercept is when x is 0. Oops. X is 0 and y is negative 1. So that shows that the y-intercept is negative 1. Or just look at the graph. It hits the y-axis at negative 1. So that means my a value should be negative 1. Or if you're looking at the original equation, there's really a negative 1 in front of here. It's negative 1 times 0.5. Your a is still negative 1. Your b value is 0.5. It is not negative 0.5. So the equation really is negative 1 times 0.5 to the x power. You can't see that. So this is the a and this is the b. Our y-intercept is 0, negative 1, and then end behavior. As x approaches infinity. Just so you know, I noticed on HMH, sometimes it puts this one first, and sometimes it does the negative infinity first. So just be careful. Sometimes they'll put the first line second or the second line first. Okay, the end behavior means what is going on with my line. So as the x is getting bigger. So if I look at my graph, as x is getting bigger, so as I'm going from left to right, if I look at the graph from left to right, the graph is going up, 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 up. It's getting bigger, it's getting bigger. But it never gets any bigger than right here, which is when y is 0. So my y values go up, 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 up until they get close to 0. Or if you look at the table, so if I start at a small number and I start going up, look and see what happens to the y values. They're increasing, they're increasing, they're increasing. They're getting close to 0. They never hit 0, but they're never going to go into the positives. So it's going up to 0. As x is approaching negative infinity. So as the x values are getting smaller. You see the numbers are getting smaller, 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 going on forever. Or you can look at the graph as I go from right to left. The graph goes smaller, 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 and the numbers go on forever. So they're going to keep going on for infinity, but they're going to go to negative infinity, not positive. Okay, let's try another one like that. Okay, negative, or f of x equals -3 parentheses 0.4 to the x power. Okay, first go ahead and graph that. Everyone needs to graph it. You're not just sitting here watching me graph. Okay, your graph should look like this. You can see where the y-intercept hits. It hits at -1, 2, -3. So our a value is -3. Your b value is 0.4. The y-intercept is always 0, comma, whatever a is. So 0, comma, -3. Okay, end behavior. As x approaches infinity, y approaches. So if you look at the graph, as x is getting bigger, I want to know what's going on with the y values. So as I go left to right, I see the y values, they go up, 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 and they keep going until it hits 0. So y approaches 0. It'll never touch 0, but it'll get close. And then as x approaches -infinity, so as the x's are getting smaller, I see the line, the blue line, it's getting smaller, 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 and it keeps going on forever until it hits -infinity. Okay, this one you're going to be doing with your groups around you. F of x equals -2 times 0.5 to the x power. Okay, here's your graph. And then, oops, answers. And then the answers are a is -2, b is 1/2, the y-intercept was 0, -2. As x approaches infinity, y approaches 0, and as x approaches -infinity, y approaches -infinity. So far, so good? Yeah. Okay. So for the rest of today, you guys are going to first work on the exit ticket. So if you go to Canvas, yes. So on Canvas, the exit ticket is there. So you'll work on it on HMH. Don't forget to take a screenshot, upload it to Canvas. Okay, I need all your eyes up here for a minute. So first, you're going to work on the exit ticket today. When you're done with the exit ticket, upload it. Then you can work with a friend when you get to the activity. The exit ticket, you're working with your groups around you. You can work with people sitting around you, but you're not moving around. When you do get to this activity, you can move around and work with friends. The activity, I did not make paper copies of it. You're just going to open up on your iPad. It's not for a grade, it's just extra practice. The answer key is up here, so you can come and check answers. It only has 4 questions. It's just to make sure you guys understand how to, especially how to do the end behavior. But that you're not turning in. Okay, questions on today? You need that on here? Final? Okay, let me stop my recording.